Hi children, this is fourth section of electrostatics. Today's topic is electric field due to an electric dipole at a point on equatorial plane. Next, torque experienced by an electric dipole in uniform electric field. And next, electrostatic potential. And next, electrostatic potential at a point due to an electric dipole. First, we will see about electric field on equatorial line. You see the diagram. Here the point is A and B and C. Here the distance of midpoint is R. So consider a point C at a distance R from the midpoint O of the dipole on the equatorial plane. Since the point C is equidistant from plus Q and minus Q, so the direction of E plus is along BC direction. The equation is E plus vector is equal to K Q by R square plus A square. And the E minus is along CA direction. So E minus vector is equal to K Q by R square plus A square along CA. So the E plus and E minus are resolved into two components. One component parallel to the dipole axis and the other perpendicular to it. So the perpendicular components E plus sin theta and E minus sin theta, it is opposite directed and cancelling to each other. The next, the magnitude of total electric field at the C is the sum of parallel components of E plus and E minus vector. So the equation is E vector total is equal to minus E plus vector cos theta P cap minus E minus vector cos theta P cap. So the magnitude of E plus and E minus vector are the same and it is given by E vector total is equal to minus 2 E plus vector cos theta P cap, since the E plus vector is equal to E minus vector. And next we can see the E vector, the total values of E total is equal to K 2Q cos theta by R square plus A square into P cap. Here the cos theta value is A by square root of A square plus A square. R square plus A square. This value you can substitute here, means we can get it this equation. E vector total is equal to minus K 2QA by R square plus A square 3 by 2 P cap. At very large distances, R vector, it is, you can consider the A. So the P vector we can consider as 2QA P cap. Instead of 2QA P cap, we can substitute P vector. So we can write minus K P vector by R square plus A square 3 by 2. You compare to R, A is very small, so the A value is negligible. So E total vector is equal to minus 1 by 4 pi epsilon naught P vector R cube. So this equation valid only at very large distances. And the next topic is torque experienced by an electric dipole in the uniform electric field. The diagram is here. Here the A point, here the B point. In B point plus Q charge, in A point minus Q charge. So consider an electric dipole of dipole moment P vector placed in the uniform electric field E. The charge plus Q will experience a force QE vector in the direction of the field. Charge minus Q vector will experience a force minus QE vector in the direction opposite to the field. So the total force acting on the dipole is 0. These two forces acting at different points will constitute a couple and the dipole experience a torque. So the total torque on the dipole about the point O is torque is equal to OA bar into minus QE vector plus OB bar into QE minus E vectors. So the total torque is perpendicular to the plane of the paper and it is directed into it. So the magnitude of the total torque is equal to OA QE sin theta plus OA QE sin theta. So the torque is equal to 2QAE sin theta. So where the theta is the angle made by the P vector with E vector. Since 2QA we can substitute as P. So the torque is written in the terms of the vector product. So the torque vector is equal to P vector into E vector. So the magnitude of the torque is equal to PE sin theta. So the special cases. The torque is maximum when the theta value is 90 degree. That means this theta value you can substitute in this equation, means sin 90 degree is 1. So the torque is equal to PE. So the maximum, the torque is maximum. The torque is 0 when the theta value is 0. So if the electric field is not uniform, then there will be net force acting on the dipole in addition to the torque. And the next one is microwave oven. Nowadays we are using in our home microwave oven. We will see how the microwave oven work. It is work on the principle of torque acting on an electric dipole. Oven produces the microwaves that are oscillating electromagnetic field and produce torque on the water molecules. Due to this torque on each water molecule, the molecules rotate very fast and produce thermal energy. So the heat generated, it is used to heat the food. And the next topic is electrostatic potential. The electrostatic potential at a point P is equal to the work done by an external force to bring a unit positive charge with a constant velocity from infinity to the point P in the region of the external electric field E. So the unit of electric potential is joule per coulomb. And the next topic is electrostatic potential at a point due to an electric dipole. See the diagram. This is the diagram and this is the point A and B. In point A minus Q charge, in point B plus Q charge. The distance of midpoint is A and A. Here the point P. So consider the two equal and opposite charges. It is separated by the small distance 2A. So the point P is, this is the point P. The point P is located at the distance R from the midpoint of the dipole. So theta be the angle between the line OP and the dipole axis AB. Let R1 be the distance of the point P from plus Q and R2 be the distance of point P from minus Q. So the potential at a P due to plus Q charge, that is V1 is equal to K Q by R1, and potential at a point P due to minus Q charge, that is V2 is equal to minus K Q by R square. So the total potential at the point P, that is V is equal to K Q, that is commonly Q it is taking away from the equation. So the K Q is equal to 1 by R1 minus 1 by R2 square. So here that means we want to find out the value of 1 by R1 and 1 by R2 value. This is 1 by R1 value and this is 1 by R2 value. By the cosine law for triangle BOP, you see the diagram here, the triangle BOP. So you can write it the equation R1 square is equal to R square plus A square minus 2RA cos theta. Commonly you take the R square from this equation, means R1 square is equal to R square into 1 plus A square by R square minus 2A by R cos theta. Here the A value is so small compared to R, so the neglecting value is A square by R square. So the remaining, the R1 square is equal to R square 1 minus 2A by R cos theta. Take the square on both sides, means R1 is equal to R 1 minus 2A by R cos theta. So we can write it in the 1 by R1 is equal to 1 by R into 1 minus 2A by R into cos theta. So we can use the binomial theorem and remind the term up to the first order. So we can write it the equation 1 by r1 is equal to 1 by r1 plus a by r cos theta. Similarly, we can apply the cosine law for triangle AOP. The next triangle is AOP. So by the cosine law for triangle AOP means the equation is r2 square is equal to r square plus a square plus 2ra cos theta. So we can write it commonly, the r square take away. So the r2 square is equal to r square 1 plus a square by r square plus 2a by r cos theta. Here the a value is small compared to r means, so the a square by r square value is negligible. So we can write it the equation r2 square is equal to r square 1 plus 2a by r cos theta. So both sides we take the square root. So the r2 is equal to r1 plus 2a by r cos theta. So again we can write it this equation 1 by r2 is equal to 1 by r1 plus 2a by r cos theta whole power 1 by 2. By using the binomial theorem and retain the terms up to the first order. So we can write it 1 by r2 is equal to 1 by r1 minus a by r and cos theta. Here the 1 by r1 and 1 by r2, this two values you can substitute in this first equation. We can get it the next equation. That means the equation is V is equal to KQ 1 by R 1 plus A by R cos theta minus 1 by R 1 minus A by R cos theta. So both sides here the minus, so plus 1 value and minus 1, it is cancelling to each other. So the remaining is V is equal to K 2AQ cos theta by R square. Here the p value is q2a, so you can substitute this p value here means k p cos theta by r square, and we can get it the value of k, that is 1 by 4 pi epsilon naught. You can substitute here means v is equal to 1 by 4 pi epsilon naught p cos theta by r square, and v is equal to, we can substitute the equation of p, that means p is equal to p cos theta is equal to p vector r cap. Instead of p cos theta we can substitute in this value here means v is equal to 1 by 4 pi epsilon naught p vector r cap by r square. And the next equation, that is special cases. If the theta value is 0 means this theta value you can substitute in this equation means we can get it v is equal to 1 by 4 pi epsilon naught p by r square. If the theta value is 0 means we can get it the v is equal to 4 pi epsilon naught by r square. Theta value is 180 means v is equal to minus 4 pi epsilon naught p by r square. If the theta value is 90 means then v is equal to 0. And the next one is, you see the diagram, that is dipole potential is axially symmetric. That is the potential due to a point charge, it is spherically symmetric since it depends only on the distance r. But the potential due to a dipole is not spherically symmetric because the potential depends on the angle between p vector and position vector r of the point. However, the dipole potential is actually symmetric. And the next one is recapitulation. Today's recapitulation. What we learned today, we will see. Electric field due to an electric dipole on equatorial plane, torque uniform electric field, electric potential and electric potential due to a point charge, and electrostatic potential and electric dipole. Thank you, children.